Hey everyone, and welcome back to section 3.1. In the last video we looked at how to graph using the rectangular coordinate system, and in this video we're going to be looking at linear equations in two variables, and our ultimate goal right now is to be able to graph them easily. So what is a linear equation in two variables? Well, it's something that looks like this: ax plus by equals c. A and b are constants, and they can't both be 0. And c is a constant, and x and y are variables. So for some examples of what a linear equation in two variables might look like, I know you're curious, we have these guys. These are all examples of linear equations in two variables. Basically, you have two variables, x and y, and there's no squaring or cubing or square roots, anything like that. You just have x and y with an exponent of 1. Now, not all of these guys look the same, but they're all linear equations in two variables. Out of all of them, this guy here looks the most similar to this ax plus by equals c. So we call that the standard form of linear equation in two variables. But we could write the remaining three in that form if we wanted to. Right, so of primary interest for us, at least in this section, we're going to be looking at solutions of linear equations. And a solution is an ordered pair, r comma t, so that when you evaluate the equation at rt, you get a true equation. And just so we're clear, by evaluating, I mean you're taking this value r and plugging it in for x in the equation. You're taking the value t and plugging it in for y. Right, so let's look at some examples. We have a linear equation negative 3x plus 5y equals 0, and we want to know which of the following ordered pairs are solutions. So what I'm going to do is just go through and check each of these. Remember that the first coordinate is going to be replacing x, and the second is going to be replacing y. Alright, so we end up with 1 equals 0, which is definitely not true. Don't let anyone else tell you otherwise. Alright, for b we have 5, 3. Hey, nice, we got a true statements. And lastly, we're going to look at 2, 6 over 5. And it's a little bit scarier because it's got fractions, but we'll just check. And we get, again, 0 equals 0. So actually we have more than one solution, which is totally possible. In fact, you're going to have lots of them. So the set of all the points in the two-dimensional plane that consists of the solutions to a linear equation is called the graph of the linear equation. So graph as a noun refers to this set, and graph as a verb refers to drawing this set. Visually, at least for a linear equation, the graph is always a straight line. That's, why the name linear makes sense. So here are our axes, and here's our line. And an equation ax plus by equals c. So this line being the graph of the equation ax plus by equals c means that every single point you can find on this line are all solutions to this equation. So we did the algebraic verification of solutions. Let's take a look at the graphical verification, which is, I think, a lot easier and a lot more fun. You know, as much fun as it could be, I suppose, in a math class. Alright, so we have a line given there, y equals 3x minus 1, and then 3 points in different colors. And our basic goal for this section is to work towards being able to recreate this picture, but for now, we're going to keep our mind on these points and whether or not they're solutions to the equation. So in red there I have 0, 1. I'm going to graph it, and 0 means I don't move left or right. 1 means I move up 1 unit. Since it's not on the line, it's not a solution. So let's look at B, 2, 5. Okay, so that means I move 2 spaces to the right, and then 5 spaces up. And yeah, that yellow point is on the line, so that is a solution. And for -2, -7, I gotta move left 2 places and then down. And that point's on the line too, so this is another solution. Alright, that about covers it for this video. In the next video, we're going to start with the actual graphing of these lines. We're going to have a couple different techniques for doing that, so stay tuned.